Hi, all APset 2020 chemistry aspirants. I hope all of you done well on the exam. And here in this video, we are going to analyze each and every question of chemistry paper 2. And this is the part 3 in the series of APset 2020 chemistry solutions. I hope it will be useful for you. And if you are not subscribed to our channel, just do subscribe for more updates and click on the like and one more thing here is if you are further interested, you can visit and join the website chemmasters.online where you can get the best conceptual oriented online courses and we will take the extra care for AP and Telangana aspirants because most of them come from the Telugu medium and their study till to the degree will be in Telugu medium only. So they will get difficulties on M.Sc and then further studies. So for those aspirants, we will take extra care in making them to understand the concepts in English. Okay, right. Now just look at the given question. The set of allo transitions among the following is. So here we need to look at the spin allo transitions and Laporte allo transitions. Here for the spin allo transitions, the change in transition must be 0, and for Laporte load delta L is in the range of 0 to plus or minus 1. Okay, now just try to check the spin transitions here 2 to 4, so that's why it is not a load, that is spin forbidden. Okay, now the next case 3 to 2, it is also spin forbidden. Now just check the 2 3 4 options here. Now 3 and 3, that is spinner load 1 and 1, spinner load 2 and 2, spinner load. Okay, now here we need to look at the L values, that is for sigma L value is 0 and for 1 it is pi, for 2 it is delta. Okay, now just check the second transition from sigma to pi, the change is 1 plus 1. Okay, and delta to delta the change is 0, and for pi to pi the change is 0. So that's why it is following, or it is simply following the selection rules for spin and Laporte. So that's why 2 3 4 are the correct answers. Okay, right. The next question: nuclear fission is a chain reaction and the extra electrons formed in the intermediate steps further attack the nuclei codes. So the first assertion is the correct one. Nuclear fission is a chain reaction, but the reason is the wrong one, because here not the extra electrons, the neutrons will be released. So those neutrons again attacks the nuclei and further it will releases further nucleus, and that means splits the nuclei to produce daughter nuclei with more neutrons. So not the electrons here, only the assertion is the correct one and or is the false. So option C is the correct option. Okay, right. The next question: which of the following statement is not correct? Mass spectrometry gives information about fragmentation pattern. It is the correct one. Isotropic distribution patterns are observed in mass spectra because for chlorine, bromine, and we can see the isotopic peaks, okay, after the molecular ion. So that's why the second statement is also the correct one. Mass spectra provides a direct structural data. It is also correct one. Based on the fragmentations, we can find the structure of that particular unknown organic compound. Now, parent ions are not always observed in the mass spectra of compound. It is absolutely wrong, because each mass spectra will show parent ion peak. Okay, so option D is the wrong one, and that is our answer. Next question: ozone toxicity to plants is generally due to the involvement of which unsaturated hydrocarbons? The answer is methylene. Okay, option B is the correct answer. Next question: which equation is an example of artificial transmutation? What is artificial transmutation? So simply human made reaction in which a nucleus is bombarded with high speed particle and which causes a nucleide to become a different type of nuclei or atom. That is called as artificial transmutation. Okay, if you look at the given four options, the definition suits for the third one, where the nuclei aluminum is bombarded with the high speed alpha particle helium 24 and producing a new nucleide by releasing neutrons. So the artificial transmutation, the example for it is the option C. Okay, right. The next question, the following reaction is an example of. So here you can see this double bond is going to attack here, and this double bond electron is going to attack here. So this double bond moves here, and that means here the 8 pi electrons and 2 electrons of this enophile. So 8 plus 2 cycloaddition, option D is the correct answer. Okay, next question, match the following reactions, column 1 with column 2, and choose the correct options here. So the first one, you can see a coupling takes place, azo coupling, right? So it is a coupling reaction. Now the second case here, pinochle rearrangement is given. So the lone pair electrons on one of the hydroxy axes and attack on proton, and water cleaves, and here is a formation of carbocation, and that is compensated by just shifting one of the alkyl or methyl group onto this tertiary carbocation to produce the product. So the carbocation intermediate is involved here, right? The third one, where the lithium aluminum hydride can attack from the top, that means just consider it is a plane of the molecule. So the hydride can attack from the top position and also from the bottom position. In both the cases we can produce two enantiomers. Okay, so one is in one hydroxy group above the plane, in other one hydroxy group will be below the plane. That means the racemic mixture will be produced here. Now in this case the base can abstract the proton from it, and then the nucleophile going to attack here to eliminate chlorine to produce the product. So simply the substitution reaction takes place. Okay, so just make the correct combinations here based on the analysis. Now the following photochemical conversion proceeds through. So here alpha, beta and gamma. On gamma carbon we have hydrogens, so the cleavage takes place, and here is a formation of OH, and alpha beta cleavage takes place. Okay, so all these steps takes place in Norris type 2 reaction. All these reactions are very important for competitive purpose in from that photochemistry. Just focus on them. So option D is the correct one. Correct IUPAC name of the following compound. So here we need to look at the bridged complexes, that is IUPAC naming of bridged complexes, okay, or compounds. So here we can start from the bridging carbon and throw that large or big sized ring. So 1 2 3 4 so sorry 2 3 4 5, and throw the bridged carbon 6 and 7. So here the functional group alkene must get the lowest locant number, okay, or substituent should get the lowest locant number. That's why we can start numbering from here only, not from here. Okay, and we need to go through the large or big sized ring. So that's why this is the correct locant numbering, and after giving the locant numbering you can simply get that 2,6,6 trimethyl bicyclo 3,1,1 hept2ene. Okay, right. The next question, stilbene can exist in two diastereomeric forms. Now just try to draw the two forms of it. Okay, so we can draw, one is trans form and one is cis form. Okay, now so stilbene can exist in two diastereomeric forms. These are they are in diastereomeric relationship. Okay, and just give X for cis and Y for trans. Now I have given X for cis because the cis compound has high solubility than trans isomer. Okay, we know that chemical properties will be same, but physical properties will be different from cis to trans isomers. Okay, right. So the solubility of cis isomer is higher than trans. That's why here I just choose cis stilbene as X, and trans-stilbene as Y. Now the boiling point of cis-stilbene is higher than trans-stilbene. Okay, so here we have given boiling point of X is less than Y. That's why it is absolutely wrong, because X is the cis and Y is trans. Okay, now stability, where the Y, the trans stilbene is more stable than cis stilbene, because which can packed very strongly with the intermolecular attractions. That's why it is very stable when we compared with the polar cis stilbene. Okay, so second statement is also wrong one. Now melting point of X is less than Y, so the melting point is very high for the trans stilbene, very high for the trans stilbene when we compared with cis stilbene. That is due to the compact packing of the trans stilbene forms in its solid structure. Okay, right, so that's why here the statement C is the correct one, where the cis stilbene is having less what we say melting point than the trans stilbene. Now dipole moment, you can see for the dipole moment of trans stilbene will be equals to 0, whereas for cis it will be not equal to 0. That is more for that X only, but here given as X is less than Y, so we can eliminate option D also. So option C is the correct answer. Next question. P and Q, or isomers of dicarboxylic acid, both decolorize bromine water. On heating, P forms a cyclic anhydride. Upon treatment with diluted KMnO4, P as well as Q could produce one or more than one from 1, 2, 3. Okay, so compounds from formed from P and Q or respectively. So here just look at the given compounds, where the first one, the mutual compensation takes place. Okay, that's why it is optically inactive, where the second, or simply they are optically active. Okay, so simply optically active pair is, that is 2 and 3, and optically inactive 1. So option D is the correct answer. Okay, right, the next question. The following molecule has, so I'm going to look at this molecule from the left side end. So if I look at this molecule from here, then this COOH will be bottom, okay, and hydrogen, that is the top of the vertical line. Now the COOH will be right side end, and this hydrogen will be left side end. Now we need to take this vertical line as a thick one, because we are looking from this vertical line only. So we need to start numbering from here, 1, 2, 3 and 4. So here you can see the direction is clockwise, so our configuration. Right, the next question. The number of mono substitution products of benzene, one benzene and prismane. Now for example, if it is chlorinated, only monochlorinated, okay, only one form is produced, because if you add any place, so simply it will give the same one. Okay, so that's why 1. Now here you can add chlorine here, or you can add chlorine here, both are same, and you can add another chlorine here or here or here or here. So simply you can get two forms of it, or mono substituted forms here. One is this one, and another one here is the one. Okay, so two of them. Now for that prismane, you can add chlorine here or here or here, at the same time here or here or here. All the places of mono substitutions will give same product. That's why only one mono substituted product is produced. So 1, 2, 1. Option A is the correct answer. Okay. Next question. The most stable carbocation. Here most of the aspirants choose option C, because it is a tertiary carbon, but it is absolutely wrong. With this tertiary carbocation, we have resonance. We need to look at the resonances also. But this tertiary carbocation, how many resonances are possible? Here 1, 2 and 3. Okay, and 4. Only 4 resonances are possible. Now for this secondary carbocation, you can see 1 and 2. Only 2 resonances are possible. And for the first one, just look at it. So here 1, only one resonance is possible for this. If you look at option B, 1, 2, 3, 4, 5, 6, 7. So almost 7, and also which can also involved here for this. Okay, 7, 8, 9 also possible for the B to stabilize this carbocation. That's why it is secondary carbocation. Still, it is more stable than tertiary carbocation because of the more resonance stabilization. So this is the typical, the somewhat the good question from APSET 2020 chemistry. Till now, we have analyzed 43 questions. In all of them, this is having something to think. Okay, so option B is the correct answer. Now, among the following reactions, tertiary butyl benzene is produced as a major product. Here is, so it is not going to produce the tertiary what is say tertiary butyl benzene, because sodium methoxide abstract protein from here and elimination of bromine and produces. So this is the product, and which is not going to produce because it needs some AlCl3, that is Friedel-Crafts reaction conditions. So it is not going to produce. And if you look at the second one, so in presence of Friedel-Crafts alkylation conditions, formation of carbocation, which is a primary carbocation, so which is not stable, that is isomerization takes place, hydrogen moves here and it produces tertiary carbocation. Now it is going to attack here to produce the tertiary butyl benzene. So second one produces the correct product. And the next case here, the double bond is going to attack on proton which comes from this H2SO4 and which produces a tertiary carbocation. Now the benzene going to attack here, so it is also going to produce the tertiary butyl benzene. Now just look at the fourth one, where the lone pair of electrons on hydroxy axis is an attack on BF3, and here is a formation of presence of positive charge on oxygen. And in the next case, what happens, the hydride shift takes place here to eliminate the oxygen. Okay, and in that case it is also going to produce tertiary carbocation, and that's why so benzene going to attack here to produce a tertiary butyl benzene. So 2, 3 and 4 going to produce the correct products which are given in the question. Okay, right. And if you like this video, please click on like and watch the video completely. And thank you very much. And if you are interested, you can visit and join on the chemmasters.online website for the best concept oriented online courses, and where you can also practice very high standard online test series to boost your success rate. Thank you very much.